Hello and welcome to The Works. Today I'll be showing you how I assembled a set of MCM legs using 11-degree mounting brackets and 5/16 threaded screws. I'm not going to cover the turning process in this video, but I will cover cutting and installing the bolt for the legs. Holding round and tapered legs squarely and securely can be a challenge. Here's how I put together a simple jig from scraps of wood and how I adjusted it along the way. This can be made into a more permanent jig, but for now I needed something fast to continue on with my project. The most critical part of this jig are the 4 brackets that go in the center of the jig. Make sure they are the same size, as we want the center of each one to be leveled once assembled in the jig. The idea here is to hold the wood square to the fence of my machine, and different sized holes in the center of the brackets will offset the taper that is in the leg. After measuring various points along my tapered leg, I compared them to my drill bits and was able to make the right size hole. A guess and check method helped here, as I made extra squares just in case I needed to make an adjustment. The tricky part here is to make sure your cut line is not inside one of the brackets, as you won't be able to see where to put the saw blade, and may hit a staple. One thing I didn't account for was the variation in leg diameter. Since I had turned them by hand, I had about an 1/8 inch to 1/4 inch tolerance in my final taper diameter. This made the fit of the leg different from one to another. See how I dealt with that later on. I made this tapered reamer for making holes slightly oblong for chair legs and other things like that. It worked for the smallest hole, but it didn't help me on the larger diameter brackets. If I had to do it again, maybe a round over bit and a router would help out here. I regret not doing that. For my largest hole size, I needed a 1 3/4 inch drill, so I used an adjustable hole cutter to do so. I'm not gonna lie, this thing kinda scares me a little bit. It's got this huge metal arm and a really sharp cutter, so I made sure to roll my sleeves up and check periodically on the hold downs to make sure that they weren't gonna collide with the bit. Then I cut the sacrificial fences from some scrap plywood, and these are used to hold the brackets in place. I was able to play around with the fit using the tapered leg here, and it's important at this point to make any adjustments and make more brackets if needed. I tacked everything together with a crown stapler to hold things temporarily. You'll see why this was important later. Make sure the staples aren't too long and don't go into your drilled out bracket. With the first side secured in place, I flipped it over to do the next side. Careful with this thing, it'll launch these legs once they come loose. Checking all of my legs for fit, I did see some issues, but I was able to continue on with the cuts. Make a mark on the desired length you want the leg to be cut to, and make sure it doesn't fall within one of the brackets. Now repeat the measurement and the checking of the fit for all of your legs. To use this at the bandsaw, I simply clamped it to the miter gauge and ran it through the miter slot. Dust collection isn't great with this jig, so keep that in mind when using it. The board at the bottom is sacrificial, so keep that in mind when you are selecting a piece for this jig. It will get several cuts through it and probably won't look too pretty afterwards. By having two supports on either side of the cut, the leg and the waist are adequately supported. This gives clean cuts and minimizes defects. This is where I ran into some trouble with the different sized legs. It either doesn't tighten into place, or my cut is falling within one of the brackets. There's gotta be a way to adjust this. Wow, look how easy that was! It also helps to plan your cuts around which legs fit into the jig at first, and which needed a modification before they could be cut. It looks like I'm having a fit problem again. Watch as I make another adjustment to this jig. With two of the brackets removed, it's a good idea to support the leg and the offcut while making this cut. Watch as I transform this cutting jig into the drilling jig. Everything is adjustable with a very large hammer, and this is where the staples come in handy. They are easily removed and allow for reuse of the drilled brackets. To get any of the staples out, I use a small hammer and a pair of diagonal cutters. A few taps and a little bit of prying, and all the staples come out. You don't have to destroy the jig as you go. You could very well just make two jigs. I was being lazy, and I didn't want to invest the time in making a proper one of these. The plan with this drilling jig is to use 3 of the support brackets from the cutting jig to center the leg in the drill press. The large bolts are only used to change the position of the middle bracket, and they don't tighten anything to the top or bottom bracket. In my design, I used two 5/8 inch bolts I had laying around, but they don't need to be this big. A 3/8 or a 5/16 would work just as well. It's important to play around with your legs here and test fit something that works. I tried a few different combinations of the legs to see what the maximum length I would need and the tallest height I would need for the side brackets. The key here isn't so much exact measurements as it is relative to the legs that you're trying to produce. My legs probably won't be the same as your legs, so just play around here and try to see what fits. Once you're confident in the measurements you took, mark the center line on your support bracket so you'll know where to drill the two holes in the sides. Remember, the size of the bolt isn't important here, it's really the length of the bolt. You need to have one that's long enough to adjust to your smallest leg and can tighten enough for your largest leg. I drilled both holes in both pieces for the guide bolts at the same time. I wanted the fit to be tight and I wanted the holes to line up. The problem with this is that I used a soft pine wood and there were some knots in the boards and my holes happened to be where those knots were. So it kind of made things difficult and ultimately ended up to some weaknesses. Once the holes were drilled, I tested the fit with the bolts, and it was really tight because I used really big bolts, which needed a really big drill, which I don't have very many of. So I really just used the threads of the bolt as a reamer and wiggled it back and forth a bunch, and it worked out. I assembled the jig with crown staples because I already had that tool out and it held the other one pretty good. Make sure the fixture is square and the brackets are in line with each other. One thing I forgot to mention is that the centerpiece needs to be smaller than the other two brackets. This will let it slide freely, so what I did was take it over to the belt sander and make it a little smaller. because I wanted to make this thing even more ridiculous, I took 2 pieces of trim board from a kitchen project and used that as the base to secure this thing to the drill press. It works. It's ugly, but it works. There's no real good way to clamp this thing, so I just flip it upside down and staple the boards to the bottom and hope for the best. It's real easy to miss here, so watch where you're shooting. Seems to be sturdy enough, but a few more staples wouldn't hurt. That's not going anywhere. Now's a good time to test the fit with all the legs. They're a little variable, and I wanted to make sure that I did this right. Now it's time to give this jig a test in the drill press. Adjust the bolts so that the legs are wedged inside of the jig. As long as a leg doesn't spin, wobble, or get held off axis, I'll count that as a success. The reason I'm using a Forstner bit here is to counterbore the top of the leg prior to cutting the hole for the threaded rod. The length of the machine threads is too long for the bracket, so I needed to be able to recess the screw deeper into the leg. In order to do that, I need clearance for the jam nuts and wrenches. Using the Forstner bit first won't cause any issues as it has a centering point. Don't drill the brad point bit first or else the Forstner will be off center. This thing works so well because the drill press itself is pressing the leg tighter into the fixture and holding it in place harder. On the last leg, no pun intended, the jig gave out. Don't use big bolts here, as it will weaken the jig. Slap a clamp on it, and it's good to go. Better than new. It passed the test, all systems nominal. Now, moving on to the brad point drill for the threaded rod holes. I sized the drill for the shaft of the screw, which left about 1/8 of an inch of material for the threads to grab into. Clean cuts, well centered, and free of burrs. Drilling into end grain is great. I use the depth stop on these cuts, adjusting it for each leg so that I only go 3/4 of an inch down into the leg. The lock on the side of the press holds the bit on the surface of the wood, then I use a ruler to adjust the depth stops. This press has been getting a lot of work lately. It's a World War II era Atlas that I bought for around $20. It had a burned out motor, but I was able to find a replacement Craftsman for about $10. Not a bad machine for a total of $30. I did have to press the chuck apart to free up the movement, but being an old Jacobs made in Hartford, it was very serviceable and now works great. The only drawback to this thing is it weighs about 200 pounds. And the only plastic pieces on it are the knobs on the handle and the belt itself. This is a benchtop press, but I'm able to swing the table out of the way to gain an extra 4 inches of working height. I mentioned before how these things will rocket out of the jig. This one took off and hit the camera. With all the legs counterbored and drilled, I use the same jig to hold the legs in place for installing the threaded rod. This first step is to put two 5/16 inch nuts on the machine threads and jam them together. If you don't know what this means, tighten the two nuts into each other. It has been done properly if either of the nuts cannot move freely on the threads. I used a lubricant for the threads here, a chunk of beeswax. I switched to liquid beeswax as the hard stuff didn't help as much as I'd like. These coarse threads can be tricky to start. Ensure that the first few turns are going in straight or you will have problems. If the leg starts to turn, readjust the jig or hold it in place with a turn screw. With the hard part done, assembling the leg to the mounting bracket is very simple. Just turn it a few times and it's secured in place. The lubricant I chose was called Tried and True. It's PLO and beeswax and works great as a finish or as a thread lubricant. Threading each leg was a lot easier with this substance. One note here, be careful not to drive this screw too deep, as there is not an easy way to get these out without damaging the threads. The counterbore limits access to the nuts, which can make it hard to loosen the bolt. With the last screw complete, it's time to pay homage to an old friend who helped us make all of this possible. The little jig that could. With that out of the way, a quick test of all the threads made sure that they engaged properly. I did the round over in a few passes. First, the miter gauge was clamped to the table and set to around 45 degrees. I was spinning the legs the whole time to try and get an even transition, but don't stress about it as this is a rough cut. The second pass, I maxed out my miter gauge to put a second bevel on it. And finally, I tried the spindle sander, but I didn't think this did anything differently. To finalize the round bottoms, I used an orbital sander clamped into the bench vise. Excellent dust collection was achieved by putting the whole sander into the hose. Don't worry, it's got a cord on it in case I need to yank it out. Keep working the legs on the face of the sander until there is a smooth transition on all sides. I used 120 grit and had good results. I'm going to hand sand these when finishing the rest of the cabinet so it doesn't need to be flawless. And there you have it. 8-turn tapered, tapped, and threaded legs in an MCM style. Thanks for watching, and let me know in the comments if you've made any improvements to this design. Maybe adjustability without a hammer? No, that's crazy talk. If you want to see what I did with these legs, check out my MCM nightstand build videos linked here.